Hi, this is Raw Automation Talk with Johnny Jones with Induasol. I'm Brent Wiederholt with Agile Automation.
What's going
How's your
on,
day
man?
going?
Oh, man, it's going great.
Good. You ready for talking about some more automation stuff?
Always, man.
All right. Well,
Always.
let's talk about the first thing: micro 1400s to micro 800 conversions. Do you get involved into this?
A little bit. I got a project that I'm currently working on right now that's in in about 3 weeks. I got to start it. The client is not happy that the conversion in CCW is working the way he thinks it should, and I told him his machines are small enough that I wouldn't worry about it. I would just take the time to rewrite the program from scratch and start with all the things that you wish that you had in the 1400 now. Um, I don't know. What do you think on that? Using
So,
converters and stuff.
so I mean, obviously, there's conversion tools from like PLC5 to control logics and slicks to obviously compact logics. A lot of times those do really well, but timers, PID loops, and that kind of stuff. So there's a few things that you need to go once you do the conversion that you actually need to go and through and fix and that kind of stuff. So is that conversion tool this kind of like similar to this where you can do the conversion, it just there's still some more work that needs to be done.
Well, I'm not old enough to have done PLC 5 conversions, or but but from what I see, it takes some of the commands and just generates a user-defined program for it with no code, so that you could write whatever program within that you want to mimic it. The time on, the time off stuff, all those things convert over pretty decently. Um, but we'll see. It's a project I'm looking forward to.
I will say this. Overall, the PLC5 to control logics and the slicks to compact logics migrations that we've done, I think most of the time we have to rewrite them anyway. So the conversion tool is nice if that's the customer that doesn't want any kind of upgrades or changes or whatever the case is, if downtime is like critical. But to be honest with you, there's so many fundamental improvements as far as the structure and organization that we almost never use the conversion tool. And I think you're right, because how long, I wonder how long he's had that 1400. And then over, say it's even been 10 years, I'm sure that there's a lot of new upgrades or new changes that he wants to add to it. So at some point, starting from new, as long as you understand what the MicroLogix 1400 is doing, as far as like a logic narrative, just convert it. Just try
Well,
to start fresh.
and I remember I met with the guy a few years ago, and I said, "Hey, you need to start planning your transition to this platform." And I remember him saying, "Nope, this PLC is never going away in my lifetime." I was like, "Yep, that's it's going to be your famous last words." And here we
Yeah,
are now.
because on the micro, I know a few of them are already discontinued because we
Correct.
started looking for them and you can't find them. It's the only ones that left are like the 1100, the 1400. I wonder if the
1400.
15,
I just had a panel that we ordered a 1400 for,
okay,
and we were able to get it.
okay, and honestly, the 1400 is a better solution than rather than the 1500 because the 1500 doesn't have Ethernet. Only the 1100 and the 1400 have Ethernet. So um, I I was just surprised on how so many people that are using those MicroLogix PLCs. So I think you might be retiring. You could retire just on the conversions of going out in the field and removing those and converting over to because what, we heard stories of 4,000 panels being built with MicroLogics, and all of those are going to have to be converted once they start reaching the shelf life and not being supported. So,
well, and what I don't get is everybody's resistance to the Micro 800 and CCW. Yes, CCW has its bugs, but so did RS Logic's 500. I don't. It's old technology, but people don't want to let go of it, and I've yet to figure out why.
yep, totally with you. Agree. Well, cool. All right. Well, then later in another podcast, we'll probably reach back to you and see how that project went.
Oh yeah, yeah. I'll let you know how that went. It should go
Okay.
pretty easy. There's small machines. I think the 1400 program was like 60 rungs of ladder. So it's not. We've talked about how we're going to clean it up. He wants some. He wants to look at programming it a different way than the way it was. We're going to try to break it out into functions, kind of clean up some of the way things were done, make it easier to work on for technicians and things like that. So
Yeah.
I'm looking forward to it.
Nice. Yeah. If I look back, that's what our college had back in the day when I was going through school. So that was a long time ago that we had RS Logix 500. It's been, I don't know how to kill it, but it needs to, people need to move forward. Anyway.
Well, in every release of CCW, it gets better. It has a simulator in it now that is in the paid for version. I mean, $500 for Allen Bradley software that can pretty much that handles a pretty good bit. Does your HMI development? You have 3 different languages you can program in. It's not a bad price, and it's pretty good. There are some quirks about it. We could call them bugs, but upload download time can be a little slow over Ethernet. It can be slow over USB. Online editing isn't bad. It can be slow as well, but it's not that much slower than 5,000 sometimes. So I don't know. I think people will make a mountain out of it.
Okay. All right. Yeah. And then does it fit the, if I were to have like a MicroLogix 1400, I know that there's like local IO. Is it possible in the same area to be able to put a Micro 800 series in there?
What do you mean?
Are you going to be having to go out in the field and start modifying panels? Because a lot of times what happens is that when you want to try to remove something, it's got to fit the whatever's new has got to fit in the same area.
It's pretty close to the same size. The 850, it's the small one, matches IO almost identically in the same footprint. And you can still, on the chassis level, you can still add a couple extra IO cards and never make it any bigger.
Okay. Perfect. All right, let's talk about HMI and SCADA systems, because this gets brought up every once in a while, and let me go to it here real quick. This is for like the people that don't necessarily get to the production floor very often. They see a touchscreen, which is typically on a machine. They actually might have had a situation where they see a couple of machines get added to their plant, and they have yet to actually have a centralized SCADA system to connect everything. So they get kind of used to what an HMI is, but they have no idea about what a SCADA system looks like and how it's better. And I would say this: HMIs have, in the last, I would say 15 years, they've gotten really powerful for the price point that they are. However, there's a couple of things that it can't do, which is typically most of the times it can't handle more users than, let's say, one, or I've seen it as possibly as high as three. Johnny, have you ever seen them do anything more than 3 users at a time?
No.
Okay. Other issues is that there's typically there's no historian. If it does log it, it might only log some data points into a CSV file. Actually, you know what? I take that back. Some of them have the capability of actually logging some data to SQL databases. Do you have anything on HMIs?
I mean, for the most part, I mean, that's becoming pretty much standard. Machine level HMIs having the ability to connect to an SQL database. That's pretty standard nowadays.
Yep.
Or even if it doesn't have the capabilities, there's usually some little workarounds to make it do that.
Nice. And then of course the price point is just fantastic, for what you're getting, because you can do alarms, you can do some, basic trending. I don't want to say like advanced trending, but some basic. There's typically never any type of reports. I guess it's possible you could do that though, especially on receipts. I've seen that. Obviously the control on the PLC. One thing I will ask you about this: how many devices do you think an HMI can handle? Because I think, to me, I've only seen an HMI handle like 4 processors at the same time.
Oh, wow. I've had a couple of projects where I have one HMI talking to multiple flow computers. I think 16 flow computers is the maximum for that one driver on this particular HMI that I'm dealing with. But then you could add another driver that can talk up to 32 Modbus devices, which could be a PLC.
Right.
There's been a few applications where it was up in the Panhandle. We were looking at ESPs. They had all the ESPs networked together, and they wanted to be able to see what was going on with them from their little central delivery point. They didn't want a SCADA system, but they wanted the operators to be able to see what was going on at them when they came to the CDP. So we had the radio network in place, we had the HMI there, and we talked to 30 different ESPs at one time from one
Nice.
HMI. We weren't doing any, I mean, we were logging alarms there locally, but we weren't doing any call outs. I mean, we had the ability to put in like a sensophone or something that we could, trigger an output or something like that to it to, do a call out. I don't know how many sensophone dialers have you dealt with in your life?
Zero, none.
You've used Win 911, right?
I've seen that. I've heard about it. They were only in the water, wastewater, and oil and gas industry, so I limited access to it.
So these little sensophone modems, you can get them now with a cell phone modem in them. You have some discrete ins. You have a couple analog inputs that you have on it, and there's a few discrete outs and analog outs as well. But you would literally record the alarm message. So when this input is triggered, it would dial a phone number, and when you answered, it would play the message. And we had one in Arkansas that we did where the guy that I was working for, him and the operator out there, they were buddies, and he wanted to have a, we were out there for a whole week. So the whole week while we were there, the first message that we programmed in was it would call him at 8 o'clock every morning and just say, "Hello, buddy. Miss you. When are you coming to see me?" So we had a little, we were using Emerson Rock there, so I had that output set to trigger at 8 o'clock every morning
Oh
to
no.
dial him and call him. That first message, he was creeped out about it.
Great use of it. That's perfect. All right. So the from both I guess from both of our perspectives, that you could actually take an HMI and go pretty far with it. And then at some point you'll reach a limit. And then typically the limit is that multiple users want reporting, and yeah, a lot more flexibility. But yeah, for a basic, it's quite surprising on how far it will go.
Oh yeah.
So with that, again, if you're talking about, I need a solution that will actually connect to multiple machines. I'm going to have lots of different users like supervisors and managers and production people. I need to pull this data up to higher executive type levels. You want SAP integration. All of these types of applications need a SCADA system. So, and would you? I mean, I think I'm fair to say that SCADA, although it's more powerful, it's going to cost you.
Oh yeah.
Versus HMI, it's typically the software is free and maybe on the slight buggy side. But once you start getting into the SCADA side, obviously you're talking about. I mean, it can go anywhere from $1,600 all the way to $30,000 and $40,000 if you wanted to. But usually you're working with software that deploys screens faster, and can build almost anything you really, really want or what you can dream. So there's just a complete set of different tools that you could use. That's my take on it. Do you have anything else to add to that, or?
Well, I think it depends on where the application is too, because we're wanting more and more of machines to do more, and as we expect more out of a machine that lands on the factory floor or in the middle of nowhere, HMIs are going to have to step it up, and SCADA may not be the perfect solution for that, or a SCADA software may not be the actual solution for that, but maybe like a SCADA light setup. I need SQL, local SQL database for historian. I need to be able to generate reports. I need to be able to do call outs. And at some point in time, maybe I need to bridge that to a bigger system. I mean, I don't know. I'm kind of on the fence about what's the right use, an HMI or an HMI with a SCADA system on it.
Right. Yep. I can see it. Yeah. There's. I wouldn't say that there's not a perfect answer for that, but I can tell you there's a weird gray zone that you can make a case both ways, and then at some point, definitely when the plant gets a lot bigger, that it's obvious that it needs to sway more on the SCADA side.
Yeah, I mean, could you imagine if you had to say you're a bottling plant and you issue an order to all your machine builders? They have to use X software as their HMI locally. And it's basically a SCADA light system. Or would you just say, hey, we just want to make sure that all of our machines are consistent. and that way it can tie into your SCADA system whenever it lands on the plant.
That would be ideal, but you're asking, you're asking that OEM machine builder to be able to be so agnostic that he wouldn't care what kind of SCADA system it would be ready for. So, ideally that would be the best solution. Is you would have a SCADA system that would control all HMIs. I can imagine just like the how efficient that would be to update and keep everything updated. Because if you walk into a typical plant floor, you typically will have like a red line, you'll have some panel view, you'll have Maple systems and Proface, and that's only scratching the surface. Yep, the Seymours from Automation Direct. So, I mean, as a programmer, as if you were a technician, to support that plant, you're going to have at least at minimum 5 different programs right alone from just that alone. If you've got all 5 of those brands, whereas a SCADA system, it would all the same tools, all the same type of look and feel. I mean, but obviously there's a cost to it, right? Getting an OEM machine builder to build something for your particular SCADA system, that's pricey.
Well, I mean, here's the other idea. Here's an idea that might solve that. Maybe you tell your machine builders, hey, no more. Maybe picking on Panel View Plus. No traditional HMI as your HMI. Maybe I want you to ship your product with a web screen. Use, I know Red Lion has this, Proface has one, Maples has one. They all have these little headless HMIs.
Perfect.
And then you have a web screen that's there for, hey, the machine just landed, that's what it's running. And then all you have to do is say, hey, after your SCADA system's in place, you just add a button to the screen that then transfers from the local HMI to your SCADA system HMI, and you're done.
Right. That makes sense. Yeah, because I mean, at some level, you're going to start getting into the MES type solutions for your SCADA system, and being able to select and pull orders from your SAP. I mean, you could do that obviously on your SCADA system, and then switch back over to your local machine HMI for control use. Yep.
Well, I mean, you could even have maybe like more of an in-depth, your HMI for the plant should be able to run that machine without the head. But
right.
If the head dies, you could switch over to, whatever plant HMI SCADA system you're using and run that machine without the head that just died. In fact, you probably would run off of that 99% of the time because that's where your recipes are. That's where you're going to get some information, all of everything that you need to know about the plant is there in front of you. And then it removes the OEM from the equation of having all that stuff there.
Yep, totally with you. Totally agree. All right, well, so another reason for a SCADA system would be like more of a control room. Mm-hmm. So anytime you're doing multiple screens or another thing that I've seen also, we've kind of dabbled into a little bit, but it's a monitor wall. So you can have 9 different types of screens displaying up on a break room, or sometimes they have them in the common room. Or they have just a large, like 80-inch screen on the hallway. So that sways it more towards the SCADA solution rather than an HMI. The other thing is that, again, the tools that you have access to once you start paying the higher price on a SCADA system, you can start getting into a lot of different powerful tools. That's it. Let's go into the next thing, trending options for ignition. This was just something that somebody was asking me about. I just want to go over it real quick. Let's see. So ignition has a couple of different trending options. This is called an easy chart option, and it allows you to pick whatever pins you want, and whatever pins you have enabled, you can see. This screen doesn't take too long to actually build. It's fairly easy for us. You can filter out whether you want different areas or different machines or different motors, that kind of stuff. We're showing just a pop-up to change some set point values. But one of the trends that everybody seems to be wanting nowadays is an ad hoc trending. Now, what this does is we've given a couple of customers the ability to store all tags inside the PLC. And the reason for that is that they're finding, even though they're heavily automated systems, every once in a while they'll have a weird, abnormal event happen, or maybe they have an operator that did something wrong, and they don't care how, but they want to trace what happened at those events. And the only way they can do that is if they start having some kind of tool that tracks and traces all of this to where they can go back to that time and date and see what happened to it. And it could be, tank levels and motor currents and that kind of stuff. It can also be on and off for like valves that are opening and closing. So that's something that they can actually just grab the tags and then drop them into the graph here, and then they can start customizing what colors and whatever they want to look at or analyze. So the time-based, you can save these for your own personal use. You can also make a couple of these charts for sharing with others. This could be, production numbers or whatever the case is, and you want to share those charts off with several employees. So those are options that are available. But you're also getting, a tag structure that's all shared, the same tag structure that's shared inside of the PLC. So most of the times we don't have to do a whole lot to provide this to the customer. It's not as expensive as most people think. But this is something for a lot of users. Let me clarify. This would be great for a few users. Now, if once all of a sudden you start getting into heavy use, the more traditional OSI Pi or Canary needs to be implemented. Those are two systems that can handle a lot more searching and querying, and can handle a lot more different users at the same time. Because once you do go into this and you are starting to look a lot of data, you are actually hitting the processor that's running the SCADA system when you do that. So obviously we implement a server that can handle quite a bit, but again, I wouldn't want 20 users to query what they've done in the last 5 years all at the same time. So
you need a bigger server then, so they can.
That's one solution to it. Say no to big enclosures. Let's talk about that. That actually came up here recently, so let's talk about that. So one thing that we probably have never ever done is purchase like one of the larger racks that like ControlLogix has, or set up a compact Logix with a whole bunch of different local I/O. And the reason is that most of our applications are spread out. So it's cheaper and more effective and more flexible if we actually do more of a distributed I/O, where we're just having the electricians run Ethernet and then 24 volts, and then wherever the I/O is where you have that remote I/O rack. So instead of having an electrician run several different cables, let's just say 5 or 6 different cables that are, 32 conductor, all in this raceway, 300 feet. Now you've got an electrician who's just running Ethernet and power, and then you've just got electrician running very, very short distance runs to that remote I/O panel. So I think the only caveat to this is maybe there would be a machine that was very, very close. So it wouldn't make any sense to have distributed I/O. But to be honest with you, there's so much flexibility with distributed. Even on a machine, I can see even still using distributed I/O. Johnny, do you have any kind of thoughts on this?
Oh yeah, I mean, I'm with you on that. It's even if the machine was 10 foot away, standardizing how you do your I/O in a plant, keep it the same as much as possible. If
Right.
you can have just a processor with your edge computer, power supply, and your network gear, and then that's what your building block is. Now it's just, hey, I need to add this piece of the plant to it. Now a factory that has a hard time spending a little bit of money to do this, they have a 72 by 60 enclosure that's going to be $100,000 to take on their full scope, and they go, well, now we could break it down to, okay, well, your first enclosure, it's going to be 25 grand. And then your
Right.
I/O enclosure is going to be, I don't know,
10.
let's say 7 to 10,000.
Right.
Okay, great. You're up and going. Now that other part of the plant, when you're ready to do it, it's another 10,000.
Right.
You don't have to change anything out. And just plug in the Ethernet cable, tie in the power. Heck, you don't even have to tie in the power there. You could have your remote I/O cabinet have its own power supply, where all you have to do is literally run an Ethernet cable.
Yep, totally with you. And let me, I mean, this is a perfect example. I already know the answer to this, but probably people don't know out there. But when you say you build a panel that's, I don't know, 48 by 24 or 48 by 36, I'm not going to say that's a large panel, but that's a decent size. Mm-hmm. That is manageable as far as shipping, as far as installing, and all kinds of other stuff. Once you start getting into these like step in, what I would almost call a step in, or modular types of enclosures that you have to kind of build all together, then the logistics of getting things through doors, the logistics of actually getting panels mounted into the enclosure, you'll actually charge more. And I'm not saying you're not wrong for doing it. The cost just goes up. So yes, it's kind of cool. It's all centralized. It's all in one enclosure, but the logistics of it is awful.
Well, yeah. And I mean, you're trying to update a currently running plant. If that plant was brand new, being built from the ground up, by all means, use modular enclosures, all that stuff. But even in a new plant, it still doesn't make sense to do that. But we're trying to update an old plant with new devices, with more I/O, with wiring that was installed 30 years ago. How do you bring new technology in and do it efficiently?
Yeah, and once you have a big large rack like that, I mean, it's virtually the downtime to swap it over is just painful. It's just almost impossible. Which brings me to a story, because I just got done doing this, but I swapped out a water heater, and what you try to do on a water heater, I've done a couple of them, but you try to set it up to where it's easier for the next guy 10 to 15 years from now. And it just seemed like the last water heater, the guy set us up to fail. And this same philosophy is true. You're trying to build something for when, 10, 15 years from now, it's easier for the other person that comes in to swap this thing out. The hardware will get old. It'll need to be swapped out. It's discontinued, that kind of stuff. And these large enclosures make it even harder. I think the only a few exceptions would be used, probably, I see them mostly used in water and wastewater, where everything's kind of centralized. But again, I think it.
But even in a water wastewater application, you know,
Yeah.
why? I mean, I get it. I mean, and I'm a big fan of hardwired. I like hardwired I/O, but I'm becoming more and more. I'm liking Profinet, Ethernet IP devices. You know, over comms. Everything's handled real nicely. It's easy to integrate. Just
You know what? Yeah. You know what? It would be a great example of this is probably, I don't know if we have the time, but figure out the cost with electrician running it the old-fashioned way without Ethernet, and then one with distributed I/O, and then see what the installation cost of that.
I can tell you the difference because that's what we're doing in oil and gas. It's 3/4 of the price less to do it. You know, we're able to deploy a system in oil and gas in, you know, almost half the time.
It's got to be. It's got to be.
I mean,
yep.
And then, oh, by the way, they didn't pull enough wires to get everything, or
yeah, of course.
or
yep.
hey, they didn't pull shielded cable, and because they thought it would be fine, and it's running next to a rack of variable frequency drives, and we're plagued with issues.
Right.
And I'm not saying that you don't have issues with running, Ethernet next to those, but it's a lot easier to replace one wire than it is to replace 20.
Right. And you know, another thing that I totally forgot about mentioning is room. You walk into a room, and then, you know, it depends on the plant or whatever the case is. Older plants just do not have any room. They've already kind of utilized the wall for something else. Having a panel that's, I don't know, 24 by 24, easy to find a location for it. Now, if your panel was, 15 feet wide, it becomes a problem.
Oh yeah.
Cool. Let's we'll move on to the next one. So let's talk about this kind of came up, and I want to kind of dive into it. So it's development areas or solutions for an Allen Bradley. So let's talk about that. So in another podcast, we talked about trying to set up a development area, reasons for it, not only to find bugs, but to also have the customer log into your system to try to also find bugs. It also allows your customer to develop documentation for procedures before it actually gets commissioned at the plant. So multiple reasons for it. Just want to go through the different solutions, I guess, to do it. So you got one solution, obviously, is the physical hardware, right? So this is currently what we're doing right now. Obviously, it's not cheap. Now, we can reuse one of our racks for multiple customers, and that's what we're doing. But if you had multiple plants and multiple projects going on, we would actually have to purchase more processors just to do that at the same time. So logistically, it's something I don't want to do, but as an integrator, this is what I'm forced to do. So one of the solutions that Rockwell came out with, which is called Factory Talk Logic Echo, I just heard about it not too long ago, and I'm unsure about the price, and I'm really thinking that it should be a part of the toolkit, which is a integrator program that they allow us to use some of their software. However, there's a couple of caveats to it, and that is that they've only decided at this moment have decided to essentially it's software that allows you to run any L8 series type program onto a let's just say a virtual machine or a laptop. I think the problem is going to be is that in the world there are so many applications that have the L7 series that this software just is not going to need. We wouldn't be able to use it. So it might be 10 to 15 years before we start seeing so many of the L8 series out there that this makes sense to move over to migrate some of our development areas over to, because it is what it is. I mean, you got to pat everybody who makes PLCs, but PLCs are fairly robust and they last for almost ever. Typically, I start seeing migrations after the PLC is about 20 years old, but you can make an argument that they'll last and run forever. So the only other solution would be is to use SoftLogics, which was something that we've used in the past, and every once in a while we actually do use it. And for everybody that doesn't know about this was a PLC that again, very similar to Echo Logic. I'm sorry, Logic Echo, but it's a PLC running inside of a virtual machine or on your laptop. There was a few issues with it, but for the most part, if you ever wanted to run something, say a small program, or say you wanted to build an AOI with a VFD, this was a perfect solution for it. Caveat was that it only runs, and they only stopped supporting it after version 23. So anytime you're running version 33 or 34, whatever the case is, this is not something that migrates perfectly all that well between the two. Do you have a question,
No.
Johnny? Oh, okay.
Oh.
I personally wish they would have just stuck with SoftLogics and then carried on with the versions, and then fixed some of their issues with it. One of the issues is that what we found when we started building large facilities with the SoftLogics is that somewhere around the 2 meg or the 4 meg size, we started seeing a lot more of where the SoftLogic was actually start crashing, or it would start having a lot more errors. A lot of times these errors we would call Rockwell to see what the issue is, but at that point in time they were like, well, A, we don't support it using a virtual machine, and then B, that's a software that's dated and old and something that we don't use anymore. So but it was incredibly powerful for what it was during that time. So if Logic Echo wants to take over SoftLogics, I'm all for it. But they've got to open it up. And currently, what I'm hearing from some of the YouTube channels is that the software is still kind of buggy. So they've got to start working on some of those bugs before we start taking that on. But in the future, from maybe potentially a couple of years from now, I can see using it. Because, I mean, I don't want to purchase all this hardware to do development areas. And if I could do that with software, that just makes it more flexible for all of us.
I agree with that.
Yep.
As long as the only thing that I could see that might be an issue is, hey, everything works great in the software, but as soon as you put it on physical hardware, all of a sudden there's an issue.
That's what we found out of SoftLogics.
And
it does.
The
answer, yeah, the answer we got the answer after you dive down into it is there's just a few rungs that we had to modify because of how the SoftLogics was scanned. So it scanned slightly different than the processor, the PLC. So we ran into that a few times, and so we had to stop using SoftLogics. That was our solution for the longest time. But yeah, again, it ran into a problem.
Or you can just do it like you've been doing it.
Well, yeah, or until somebody on LinkedIn can, or anybody out there can, or watching this post can find a different solution. Okay, so we talked about that. Let's talk about the ratio of machines that need to be connected versus the machines that have data clean enough. So I guess this is coming up because we're kind of faced up with some MES type projects right now at the moment. And some of these machines from the OEM side do have the available tags ready to go. But I would say that every single machine that we have to look at, we have to actually dive into the code, look and analyze into what's available, what's not available, find out whether their tags actually are standard, just like the other OEMs. And usually we find they're not. So every single machine we're looking into, we seem to have to clean those tags up to where they're more standardized. I can tell you a perfect example is a lot of times a typical OEM machine has alarms, and usually it's your typical alarm screen that just shows you that there's a bunch of alarms that just happened. But the problem is that on an MES, when you're trying to track down which alarm was it that caused the problem, that you need to then add, what we do is we add logic to that PLC to make sure that the alarm that actually caused the problem is the one that actually gets written up as being the problem of the downtime. We call it a alarm first out.
Yep.
And the consecutive alarms that happen are just a byproduct of that alarm. But we need to ignore all the rest of it and just focus on the one that was the initial cause of it. So all of those, I've yet to see an actual OEM machine builder actually include. So anyway. So as far as the ratio of machines that need to be connected versus the data that needs to be clean enough to be clean, I'd say, here in the United States, I mean, we're still trying to connect systems. And then once we do connect to it, all of them need to be, reviewed and worked on just to clean them all up. And I'm sure the main focus of an OEM machine builder was not OEE data, even though that may be something that they might be doing now, but definitely in the last 20 years, that was not something that they would care about.
Well, I mean, and it's a prime opportunity for OEMs to go, hey, we can have this as a option
Right.
for a fee. We'll come in and we'll set it up. We'll give you, or we'll ask you what is the, how deep do you want to go?
Oh yeah, and unfortunately, it goes as deep as you really want it, right?
Yeah.
Because I mean, you can get just the simple tags of like just running and idle and stop, but then you're like, okay, well, I want more. I want reason codes, and I want production target rates, and I want hypothetical production target rates, and so it's never ending, really, to be honest.
And then, hey, what operator was at that station?
That is really important.
You know how easy that would be to do is with a little RFID badge and a little proximity reader.
Right.
SCADA system goes, hey, Joe Blow was at the machine when it crashed. Joe Blow's not supposed to be by that machine. What's he doing there?
Right. Absolutely. So let's talk about processors and IO agnostic. So we're running into a problem right now at the moment where you got supply chain issues, right? So sometimes our only solution is to buy the processor by itself and then to have whatever kind of IO you can find. So This IO doesn't need to be point IO. It could be Turk. It could be Groove. It could be anything you really want. Anything you can get your hands on, it could be. I do know that some of the local IO on Allen Bradley's is hard to find. So right at the moment. So doing it like this, it just come out Ethernet. You add whatever you want. You wire that up to your panel. You're done. It doesn't have to be Allen Bradley. This is what I would feel is a better solution to the supply chain issue, and also potentially what is a great solution for years to come. So right now, at the moment, we've got a couple of machines that are ran by Siemens, and the customer has asked us to swap those Siemens out to a Allen Bradley. So it is physically more difficult to swap out local I/O on a machine, and if it was set up where the processor was separate, we could actually just quickly add another processor to the machine, test out the logic, and if it worked, we could just do a processor swap out. So if this was a Siemens, and the customer asked us to swap it out to an Allen Bradley, that is a migration that is easier to implement. So, and if this version becomes discontinued and you wanted to swap it out with something else, again, it makes it easier to for the migrations. And again, just like the analogy for the water heater, you're trying to set it up for the guy doing the swap out 15 or 10 years from now. So,
yeah, but the problem is, like, you take a machine that was built, even if it had, I can't remember what it was called. What's the coax that Allen Bradley?
Oh, you're talking about, yeah, control net.
Yeah, control net. Yeah, I mean, you can't really go to a different processor for that and still use the I/O that's there, right?
No, you could control net there's a control net instead of the Ethernet, there'd be one for device net, one for control net,
okay, so
and
you would just change the bus coupler out then.
That's it. Okay. Yep.
All right.
Cool. So let's see standard deviation. Let's talk about that real quick. So we had a customer that was scanning packages using a high-speed scale. So these packages would be, I wouldn't fairly quickly. Let's just call it that. So as it starts storing this, ideally you would just go straight to storing every single package into SQL. Only problem is that you can't hit a SQL database that fast, that quick. So our solution was to actually store some of that and buffer that inside of a PLC, and then have the PLC actually, using a large, like a batch, throw those data sets over into the SQL database. So this gave us the ability to almost real time start seeing whether the customer was actually overfilling or underfilling. And based on that, he could actually see on the screen that he might be, going over on overfilling. And so he could actually adjust the filling equipment to back down to where it's a safe run. That way you're not jipping anybody out of some material, but you're also not giving away so much. When you go to the grocery store and it says that it's 100 ounces or whatever the case is, I always thought that was fairly accurate. Turns out that they are.
No.
Depends. It depends on the time in the week and the operator, but that can fluctuate quite a bit. So,
hey, in that common bottling machine that we both touched at some point in time in our careers, when that machine was running on point, it was on point versus the mechanical fills that were all over the place. But they couldn't handle that 1 out of every 200 bottle rejection.
Yeah,
or there might be there might be 20 bottles in a row that just didn't fill. So I get it.
So this gives the operator or a user the ability to see almost real time. We do give them the ability to kind of select what a product they've run fairly recently. But we had to take it a little bit step farther because we had a customer going, well, in the last 3 months, I want to see some data. So, and I want to be able to filter out by the plant, by the line, by the product, by the shift, and then that gives them the ability to see the which line and which shift and which product is the worst. So they're able to kind of look back 3 to 6 months and hone in not just anywhere, but which ones are the worst. And if there's a commonality to that, they'll start figuring out, what they need to fix and what kind of settings they need to adjust to fix that. So this is definitely a higher level view. Of course, when anytime when you can store some data inside of SQL, you get the flexibility to being able to manipulate and to filter whatever you would want. So, all right. So let's go back to, we already talked about that. Oh, let's talk about the 2 panels. Oh, maybe it's just the 1 panel that you're working on. Talk about that. So let's take a look. Obviously from the first, millisecond off, so looking at it, you have, if I'm not mistaken, this is a complete, besides the enclosure, Phoenix Contact product.
Pretty much. The HMI is Proface for the web HMI. This is an application where we had to put batteries in the bottom of it, so that's why there's a big gap on the bottom. We had to move everything up.
Okay.
It was supposed to have smaller batteries in the beginning. Customer last minute said, "Oh, hey, we want to up the battery size," and so yeah, we had to move everything up. But yeah, it's our second PLC Next project that we've done.
Okay.
And been pretty happy with it.
Good.
I'm ready to throw away everything Rockwell for it.
One question I got, I've never seen this before, but to hold that Proface up, I get you have these little, I don't know what you would call them, little mounts that would hold it towards the panel or the hole that you've got.
Yeah.
That hold it on the enclosure. But I've never seen the actual. It looks like you've got more additional screws than around the outside. What is that?
Oh, that's because this unit will be outdoors. That's an actual enclosure that's wrapped around the HMI to protect it.
Okay, is that Phoenix content, or is that a Proface type product, or is that is that universal?
I get them from. This is a Rital enclosure. That's a Rital add-on.
Okay, nice. Okay, perfect. Yeah, I mean, it looks nice. Looks like you're taking the outputs and throwing those to relays. All your inputs are going to terminals.
And what's funny is this is a distributive network too. So there's 4 more node boxes that go to this.
Gotcha. Okay. And one nice thing about that, the Phoenix Contact right there, even though the PLC Next is a processor, it's probably what the 2100 series or the 1100 series.
2152.
Okay. That you could easily remove that and then purchase the Ethernet module or the Profinet module. So you can make that as a remote I/O that doesn't have a program in it if you wanted to.
Or just leave it the way it is. It'll act
Yeah,
as I/O. It's about the same price too.
Yeah, that's the funniest part about it. What's the device next to that, to the right of that Ethernet switch?
That's a UPS. Oh, I'm sorry. I'm looking at the wrong one. Oh, that's a Profinet to Modbus gateway.
Oh, okay. Interesting. Okay. Cool. Anything else you're working on?
We're doing, I got a 5380 program that I'm working on. I sent you the picture of that one too, if you want to pull that one up.
Oh, I deleted them. Sorry.
Oh, no, it's a, we're using Snyder IO with Alan Bradley.
Nice. Okay. And then, was it cost that you wanted to switch, or you just wanted to Was there any kind of feature or added bonus to using Snyder IO?
Cost was one, availability was the other.
Okay.
You know, the client was, well, can we keep doing this? I said, please don't, because it's like kissing cousins. You know, you just don't do it.
Right.
Right now, everybody understands it, but shipping out panels like this with Allen Bradley processor and Snyder IO, it adds a little bit of complexity to it because it's two different softwares that you have to deal with. But yeah, it works pretty well.
Okay. Perfect. Anything else to talk about, or
I don't know.
are you good?
Industry 10.0. When's that coming?
It's whenever the marketing team decides to want to switch over to talking about something else.
Luckily, I'm working on IoT 11. How about that?
Perfect. All right. Well, thanks. I appreciate your time, Johnny. It's always been great. Thanks to everybody for listening and watching.